Question 13, and we've got a question about vectors. We've been given 3 points. 2 points we know completely. Point C has got a constant in it, which we've later got to find. And we've been asked several questions about the arrangement. I think it's always a good idea in these vector questions just to draw the roughest sketch of what's going on. And there is that sketch. Point A, point B, and well, point C I've drawn as a line because I know the I coordinate of the vector, but I don't know the J, so the J could be anywhere along this line. But first of all, we're asked some questions about AB. Let me put the line AB in. And we've been simply asked to describe the vector AB travelling in this direction, what it is in vector terms. To do the journey from A to B, we have to travel back to the origin from A and then go out to B. So the vector journey back to O will be the negative versions of our components here, the I and J components here, but the positive components of the position vector of B. So writing that down, and I can do this in column vector notation. So first of all, the negative versions of the position vector A plus the positive coefficients of the position vector B. And this is equal to negative 18 and 12. And that's your answer to part A. Oh yes, if they did want it in ij notation, this is equal to negative 18i plus 12j. For completeness, there's the answer again. Part B, they want the magnitude of this. So we just do the Pythagorean relationship between 18 and 12. So the magnitude of AB is equal to the square root of 18 squared plus 12 squared. Given that we're squaring, I can ignore the negative sign here. And we've been asked to present this as a fully simplified surd. And if you do the maths on that, you get 6 root 13. So there's the answer to part B. So part C. So we're now told that A, B and C, this now being C, and if C lies on AB, it must be the fact that AC is a proportion of AB. So writing that down, we get this. AC is a proportion of AB. AC is the journey from A to C. And this in column vector terms is this position, take away this position. So here's AC and here's AB. So assembling our relationship here with K, we get, and we can split this into two equations. So looking at the top line, I get negative 12 is equal to negative 18k. And the bottom line, p plus 3, must be equal to 12k. Now, between these two equations, we can work out both the value of p and the value of k. So coming up here, from 1, we get that k is equal to 12 over 18, which is 2 over 3. And if we sub k is equal to 2 over 3 in 2, we'll get that p plus 3 is equal to 12 times 2 over 3. The 3 goes into the 12 4 times, and therefore p is equal to 4 times 2, which is 8, minus the 3, so p is equal to 5. And that's the answer to C part 1. So if I move my diagram along a little bit, let's just finish off with C part 2. State the ratio of the area of the triangle of AOC to the area of the triangle AOB. So AOC is this little sliver here, and AOB is the bigger little sliver, if you see what I mean. Well, they're dependent on the length ratio of AC to AB. And we know that AC and AB are linked with our equation here. So substituting K into our relationship for AC and AB, I can say that AC over AB is equal to K, which is equal to 2 over 3. Again, this is almost impossible to see, but given that the height of the two triangles are the same, that being H, the areas must be in the same ratio. So I can say that AC to AB is equal to 2 to 3, and therefore the areas AOC to AOB must also be in the ratio of 2 to 3. And that squeezing it all in is the answer.